All right, today we are going to do some more addition and subtraction of these rational expressions, but we're going to start out with our denominators in non-factored form. So you notice yesterday all of our denominators were in factored form. We didn't have to do anything, and we just had to multiply each fraction by what we were missing. Today we see that the denominators are not all factored. So before we do any of these problems, we need to make sure to factor the denominator if possible. And then we can do what we did yesterday and multiplying both fractions to get a common denominator. All right, so we have x plus 2 is our denominator here. X squared minus 4 can be factored to x minus 2 times x plus 2. So 4 over x plus 2 minus 6x squared over x minus 2 times x plus 2. Now that first fraction is missing the x minus 2. So we're going to multiply the top and bottom by x minus 2. So it's going to be x times 4 is 4x. Negative 2 times 4 is negative 8 minus 6x squared all over x minus 2 times x plus 2. Combine like terms. Well, we don't have any like terms here, so we're going to rearrange this as negative 6x squared plus 4x minus 8 all over x minus 2 times x plus 2. And we're going to factor a GCF from the numerator of a negative 2. And then factoring out negative 2 will leave us with positive 3x squared minus 2x plus 4 all over x minus 2 times x plus 2. And then again, we want to see if we can factor that numerator. All right, so we're going to guess and check this and say we have this negative 2 in front. And we have to multiply to get 3x squared. So we have 3x and x. We have to multiply to get positive 4, but add to a negative number, which these both have to be negative now. So we can try negative 2 and negative 2 and see if these add up to get negative 2x. Negative 2 times x is negative 2x. 3x times negative 2 is negative 6x. That's not going to work. So the only other option is 1 and 4. Okay, 3x times negative 1 is negative 3x. Negative 4 times x is negative 4x. That's going to add to more than that. So we can't factor this. This is unfactorable, which means this is our final answer. All right, example 2. We don't have a common denominator, but we don't need to factor anything. So we can multiply this by 7 over 7 and this by 4x over 4x. This is going to give us 21. 7 times 3 is 21 minus 4x over 7 times 4x is 28x. And then I'm just going to rewrite this to put the negative or the leading coefficient up front. So negative 4x plus 21 over 28x. All right, then we go and see, can we factor this? Well, the numerator, we can't factor anything from that. They don't have a GCF. So that's your final answer. All right, example 3. All right, so the first fraction we can't factor the denominator, so 3x squared stays on the bottom, but the second one we can factor out a 3x, and we are left with 3x minus 4. Okay, so now the first fraction is missing the 3x minus 4. So I'm going to do 3x minus 4 over 3x minus 4. The second one looks like it has everything, but it's missing an x squared, because the denominator here is 3x squared. This is just 3x. So we have to multiply by x over x. So 3x minus 4 times 1 is just going to be 3x minus 4 plus x times x is x squared over 3x squared times 3x minus 4. Combine like terms in the numerator. Well, we don't have anything that's exactly the same, so let's just rearrange this in standard form. 3x squared times 3x minus 4. All right, so then we look at that numerator and ask ourselves, can we factor that? Two numbers that multiply to negative 4 but add to positive 3, well, that's positive 4 and negative 1. So x plus 4 times x minus 1 all over 3x squared times 3x minus 4. And we don't have any common factors on the top or bottom, so that is just going to stay just like that. So don't think that just because you can't cancel anything means that you factored incorrectly. Sometimes we're going to have that situation. All right, so example 4, we have 3 fractions. So when we are looking at the denominators, we have to make sure they all match. So the first step again is going to be factor. So the first fraction, there was nothing we could factor. The second one is going to be factored x plus 1 times x plus 2 minus 4x, and then we can factor out a 3 and get x plus 1. Okay, so they all have x plus 1. The first one is missing this 3 and the x plus 2. So we got to multiply by 3 times x plus 2 over 3 times x plus 2. Now the second one is missing only the 3. So I'm going to multiply 3 over 3. The last one is missing just the x plus 2. So x plus 2 over x plus 2. Okay, so the first one, 3 times x plus 2, distribute the 3. We get 3x plus 6 times 1, so that doesn't change anything. Plus 3 times 3x is 9x. Minus 4x times x plus 2 all over our common denominator. So now I'm going to distribute this negative 4x. So we have 3x plus 6, not 6x, plus 6, plus 9x minus 4x squared minus 8x, all over that common denominator. Combine our like terms, we have negative 4x squared. 3x plus 9x minus 8x is positive 4x. And then we have plus 6 over 3 times x plus 1 times x plus 2. We can factor out a negative 2 from the numerator. So negative 2, and then we have 2x squared minus 2x minus 3 all over 3 times x plus 1 times x plus 2. Now we have to check, can we factor that numerator? It is not factorable, so for the sake of time, I'm letting you know that you can't factor that, but you do want to check these, guess and check and all of that. All right, the last two problems here. We can't factor the first one, but we can factor the second one. We can factor out a 5x, and we have an x minus 2. Now, one of the strategies you can use is instead of multiplying the first fraction by 5, you could look at these numbers, your numerals, and say, wait a minute. If I multiply that 5 by 2, I get 10. So I can multiply this second fraction by 2 over 2, but I also have to multiply it by x because there's an x squared. And I only have x to the first power. So I'm going to multiply by 2x. The first fraction I'm going to multiply by x minus 2 over x minus 2. So if we look at this, x minus 2 times 3 distribute, we get 3x minus 6 plus 2x times 2x is 4x squared all over, well, if I have 5x times 2x, that is 10x squared, and we have x minus 2. So notice I just looked at this one to show you that, hey, if I do that, I get this here. 5x times 2x. Multiplying we can do in any order. All right, then we can rearrange this a little bit and do 4x squared plus 3x minus 6 all over 10x squared times x minus 2. Right, so one of the things about these problems is that they can start simple and then they can get out of hand or explode into something messy pretty quickly. We can't factor this, so that will be your final answer. All right, this last problem, I can factor the denominator of the first one, factoring out a GCF of 3, and we get x minus 3 times x minus 5. Now, the second one, I see that the denominator can factor to x minus 5 times x plus 1. Generally, we can't factor the numerator beforehand, but when I look at this, I say, wait a minute. If I factor out a 2, I get x plus 1. Well, because we have in this fraction an x plus 1 on the top and bottom, I can cancel that. That is going to make this problem significantly easier because now I have x over 3 times x minus 5 minus 2 over x minus 5. And the only thing I have to do is multiply the second fraction by 3 over 3 because they both already have an x minus 5 factor in the denominator. So I have x minus 6 over 3 times x minus 5. We can't simplify that, so that would be our final answer. Now, if you did not see this canceling earlier, that doesn't mean you couldn't solve the problem. It just made it take a bit less time. So, yeah, this process is complicated because there's so much you have to think about and do. You have to factor, then you have to multiply, and then do your algebra work to get your simplified answer, and then see if you can simplify it further once you combine like terms. So these do take practice in order to get good at. So make sure you're doing the problems and taking your time. So thank you for watching. Make sure to like and subscribe.